Good morning. We are thrilled to have the just before lunch speaking slot. We're going to speak to you today about document classification at LexisNexis and the ways we are looking to leverage topic aboutness scores in our product offerings. My name is Mark Shewhart. I'm a data scientist at LexisNexis. With me today are Sophie Lagace, lead legal taxonomist, and Kimberly Hoffbauer, lead news taxonomist. Next slide. RELX is a global provider of information-based analytics and decision support tools for professional and business customers. We have over 33,000 employees in 40 countries. If you see here are some of the major RELX businesses. Next slide. Let's just look at LexisNexis. We help our customers do their jobs better and faster with information, analytics, and technology. And a little bit of foreshadowing. Notice the wide range of customer roles and content. We have lawyers, corporations, universities, governments, and the assorted content that they are interested in. Next slide. LexisNexis itself has a wide range of markets, users, and content. While this is a generic intro slide, this speaks to the challenges of the varied needs and content that we have. And kind of a side note, LexisNexis was the world's first commercial full text search engine introduced in 1973. That's way before the 1996 of Google. And a funny note, but this is true, in the 1970s, search engines were unknown to lawyers. Our search engine produced results in about 1 to 2 seconds over a much smaller collection than we have today. However, we deliberately delayed the search results by at least 5 seconds so these users would trust that the search engine was thinking. Now, compare that to what people expect today. Next slide. Okay. You'll see later how we leverage taxonomies and classification in LexisNexis products. We have hundreds of millions of documents that we need to classify to over 30,000 topics. And we reclassify all this content regularly as the taxonomies grow and the rules or models are improved. Clearly at this scale, the classifications must be automated. Now, we use multiple technologies to classify vastly different content types. And let's give an example of the differing scopes. Consider a simple 300-word news story versus a 50-page court opinion. Now, a news story is generally easy to see why it was assigned a topic, generally. But legal researchers who look into case law are interested sometimes in that needle in a haystack, no pun intended, a single paragraph that a judge wrote within those 50 pages that is about that topic. They were looking for that tiny little paragraph about the topic is binding law in the US and in many other jurisdictions, but certainly in the US. Now, other times legal researchers want cases that kind of speak broadly to the topic, broadly and deeply, because they're doing just introductory research, etc. Those are two vastly different needs for those long court cases. Hence, consistent confidence scores everywhere, every topic. And we'll explain confidence scores later, but I might add for this audience, these are not machine learning model probabilities that you may be familiar with. Some ideas surface higher scoring documents to the top of a results list or expose the highest scoring topics on the face of a document. And if you're doing filters and alerts where you get things daily on topics, you may set it to only topics above a certain score threshold. So next slide. Okay, the requirement, again, consistent confidence scores everywhere, every topic. Anywhere we assign a document level topic, the topic gets a confidence score. And anywhere includes a wide variety of classification technologies and in addition to the wide variety of content types. And we say predict aboutness here. And we're going to define aboutness as simply breadth and depth of discussion of the topic. So a tiny little paragraph about a topic in a 50-page case is a little bit less about a case that discusses the topic throughout its entirety. Now, with varied technologies, we need a score that is consistent. We need a uniform scale with consistent meanings, and we have 4 defined score buckets: very strong, strong, passing, and then marginal or weak. And we also measure our search engine relevancy at LexisNexis by grading results to this 4-point scale. Now, everywhere we leverage taxonomies and our varied content types, we can enhance relevance, product functionality, and consistency of user experience. With consistent confidence scores everywhere, every topic, our application developers and UX designers have a common framework to leverage taxonomies, another advantage. We are still imagining how we can further leverage this to continue to delight our customers. Next slide, and I hand it over to Sophie.
Thank you, Mark. So yes, we will show you the various ways in which our topical classification is offered to users at LexisNexis. And throughout the presentation, we will mostly cover 2 of our products: our online legal research product, where users will go, and our users in that case would be mostly lawyers, legal practitioners, and they will go on our products to search for legal content. So to search for cases, legislation, briefs, textbooks, that sort of content, to find documents that will be relevant to the case that they're working on. So that's one of our main online legal research product, but we also have our news and business product, which Kimberly will cover. And in that product, users will mainly go to search our news and business content. As Mark said, 2 very different types of content that we classify. So here on the top of the screen, we see a screenshot of our Canadian product, Lexis Advanced Quick Law. And on that product, a user could go and run a search on the keyword hearsay, and they could add a practice area to their search because maybe they're interested in civil evidence as opposed to, let's say, criminal law. So they can add that topic to their search. But they could also run that search on hearsay, and from the results page, add a topic via post filters, and they can drill down to the topic of their choice. They can also browse our full classification. So here we see the Canadian classification. In Canada, we have less than the US. We have about more than 4,000 topics. We are bilingual. We cover 2 legal systems, civil law and common law. And users can go into our classification and browse through, pick the topic of their choice. Here they might pick the hearsay rule topic, and then they can either get all the documents tagged to that topic, or they can add that topic to their search and add their own keywords and run that. Or they could create a topic alert and get a notification whenever a new document is loaded online that was tagged to that topic. So, oh, sorry.
So Nexis is one of our news products where we apply our smart indexing. Smart indexing is what we call our news classification. We apply the news classification to at least 6 or 8 products within our LexisNexis portfolio. We have several ways to find and add classification topics. We have 2 ways to do pre-filters. One of them is our topic lookup. And for smart indexing, we offer subject, industry, company, people, and geographic classification. So what you would do as a user is click on one of these. For this example, I'm going to select a subject topic. So I would click on that, and it opens another window where I can browse our subject topics. And here I'm going to search for cryptocurrencies. So I type that into the search box. I click enter. And what that does is it shows all the results for where a cryptocurrency appears in our taxonomy. Our taxonomy is polyhierarchical. That means you can find our topics in more than one place. So in this example, I get 15 results for cryptocurrency. Here's just a couple of examples. So to add this to my search, what I'm going to do is click on the box next to cryptocurrency, and that will include all the child topics. So you also get, in this case, cryptocurrency crimes. And then our other pre-filter is our word wheel. What I like about the word wheel in the other pre-filter, you have to know exactly what topic you're looking for. With the word wheel, all you have to do is start typing in crypto, and it's going to show you what topics we have that start with crypto. So in this case, again, I'm going to select cryptocurrency. I'm going to click on it, and that'll automatically add it to my search. You can add multiple topics to your searches, and the default is and. If you click on the and, it will give you an or. If you click on the or, it will give you an and not. So in this case, I'm thinking, I'm not interested in the cryptocurrency crimes topic or documents. I just want to search on cryptocurrency. So when I execute that search, here's just an example of the top few documents that I get for cryptocurrency. We also have post filters in our Nexus product. So if I do a search on Ethereum, here are some of the results I get for that. And then to the left-hand side of my results page, I will see my subject and industry topics. These are the top-level topics that are listed on the side. And what you do is you start drilling down from there. So I might select banking and finance, and I'll start drilling down from there to find my cryptocurrency topic. And then I will narrow my search results from that point.
All right. So what are the advantages of searching using a classification? There are a few. I remember when I was practicing as a lawyer way back in the early 2000s and sitting at the computer, and online legal research services were just emerging, and I was searching in one of those and just wishing that I could just have a classification given to me and search on a topic and not have to draft my own search. So it really is something from our NPS comments. Users really, legal users and news and business users love searching using a classification because they can easily and quickly access results on a given topic. Maybe they're not super familiar with their topic and they're not sure how to draft their search exactly. So it's a really good starting point and you get quick results without too much effort. You might want to add context to your search. So earlier I was showing the example of searching for hearsay. Well, if you're interested in civil hearsay, you're not as interested in criminal hearsay. So you have to kind of specify that, or else you're going to get a lot of irrelevant results for you. If you're searching for a concept that has many synonyms, it's also going to be really useful to use a classification. For example, if you're searching on the topic driving while intoxicated, if you're going to draft your own search for that, you have to utilize a whole bunch of vocabulary because it can be called offenses relating to conveyances, impaired driving, DUI, DWI, driving under the influence, drunk driving. So you have a big task ahead of you if you're going to draft your own search. So using a topic in those instances will cover you and you won't have to do that. And then if you're searching for search terms that are really common or ambiguous, for example, in the legal field, if you're searching for the topic negligence or competition, those are common words, and if you just search on those words, you might get things that aren't really relevant to what you're interested in. So using a topic, again, in that instance will be super useful. In the news field, if you're looking for the actor Will Smith, you're not interested in anybody named Will Smith in your search results, or of course Apple, the company versus the fruit, or like something like Georgia that can be a country or a state or a person's name. So again, like using a topic is really useful. So the last example, just to show you in which instances it's really useful to do that. If you might be a lawyer and you're looking for disciplinary sanctions for inappropriate behavior outside of work. Well, we have a topic for that. It's called off-duty conduct in employment law, and it's a lot easier to search on that than to try to draft a search for that very long topic that has many components. So those are examples of why our users want to use our classification. And so how do we do classification at LexisNexis? Of course, like Mark said, it's automated classification, because we classify virtually all of our content and all of our content types. That's millions of documents. We cannot possibly do that manually. So we use a variety of indexing tools. So for legal and for Canada and other jurisdictions as well, we mostly use Boolean rules. So each of our topic, for Canada, we have, as I said earlier, about a little bit more than 4,000 topics. Each of our topics has a complex Boolean rule that was written by a lawyer who tried to reproduce as best as possible the various ways in which a document could deal with a topic, using synonyms, variants, and just making sure we get good recall. And for the past decade or so, we also started to use machine learning. So we're also using that, and we do have machine learning models for certain of our topics. And in Kimberly's area for news and business, they have a technology called smart indexing, which was actually invented by Mark here, and where you use different requirements, frequency and weight requirements associated with variant terms. And here we've got the example rule for cryptocurrency, where a single occurrence of a term 1 causes a document to tag. So these are like all the main ways in which we create our baseline indexing. And we also, it's important because we're using automated classification, it's important to measure our precision. And so previously we were doing that in spreadsheets and not necessarily in a systemized way, but since last year, we have a new functionality in an internal tool that is called the Search Test Framework, the STF tool. That's a tool that you've probably heard about here at this conference, where they do human relevance testing of search algorithms. But since last year, we've worked with Doug's team, who is responsible for this tool, and we've integrated functionality to measure topic precision. And measuring topic precision is different than measuring search algorithms. So we have our own little set of metrics in there. So when we run a topic precision test, we will grade a number of documents on a given topic, and we will grade those documents on a scale of 1 to 4, just like in the human relevance testing, going from a weak or a bad hit to a very strong reference to the topic. And in this scale, gradings of 3 and 4 are considered major references, and a grading of 2 is what we call a passing reference. And of course, the 1 is a weak or a bad hit, which is not considered a good hit in any of these metrics. So we mostly use 2 metrics. We have our major reference precision, where we consider gradings of 3 and 4, so strong and very strong documents, as good hits, as true positives. But we also have our minor reference precision, where we consider gradings of 3 and 4, strong and very strong, but also passing references as good hits, true positives. So if we look at this table here, where we've got 10 documents graded on that scale of 1 to 4, we've got 1 document that's graded a 2. Well, in the major reference precision metric, we have 70% precision, and in the minor reference precision, we have 80%. And we want to capture that because those 2 metrics will tell us a different story. We're interested in having those passing documents because lawyers are interested in the high recall. They don't want to miss anything, but we do want to know what the difference between these 2 are. And if we have a topic that has a very high minor reference precision, but quite a low major reference precision, we might look at that topic and intervene on it to improve its precision. So we are now tracking precision in a systemized way, which is great. So here we see what we call our pyramid of classifiers. So we do use a variety of indexing tools and rules at LexisNexis. We've worked really hard actually in the past years to up our game, and we don't just rely on our baseline indexing rules. So at the base of the pyramid, we have the rules that we use to build our recall, so the Boolean rules that I mentioned, the machine learning models as well. But we use other tools because we believe that each of these tools will address an indexing challenge from a different angle. And when you put all these tools together, you really optimize your precision. So I'm just going to give a couple of examples, but like source inclusion if you have a source or a publication of a topical nature, like a criminal law textbook, you're going to want all the documents from that source to be classified to the topic criminal law. Inversely, you might want that source to not be indexed at all to any civil law topic. So we ensure that this happens, and we're thereby increasing, in the example of source exclusion, we're increasing our precision with no loss of recall because we know those documents aren't relevant to those civil law topics. So we also had override lists where we can manually add a topic to a document or remove it in 24 hours. So, and we have other types of rules, and all of these together really ensure that we have optimal precision and recall. But even doing that, it's not enough. So we need to go beyond that and also worry about relevance, because even the best indexing rule with a really good F measure, you're still going to get a variety of results. You're going to get those very good references, those passing references, the occasional more marginal or bad hit. So we need a way to distinguish between those results. And that's where the confidence score comes in. So on this slide, we see two documents that are tagged to the topic damages for psychological injuries. And they have very different relevance. The document on the left has a very strong reference to the topic. It has a lot of vocabulary. It includes a definition of the topic. So it's obviously, it has a great deal of aboutness. The document on the right mentions that the plaintiff claimed damages for emotional distress, and it's being denied, but there's no real discussion or depth and breadth of discussion in that case. So if we're just tagging a topic in there and it's a yes or no thing, it corresponds to the rules or it doesn't, we're not making that distinction between these two documents. But what we're doing now is we're putting in a confidence score telling us that the document on the left has a relevance of 89 and the document on the right has a lower relevance of 59. So Mark will tell a little bit more about what these scores mean.
Okay, now remember, we have multiple classification technologies across vastly different content types. So this isn't just one type of tool that's applying the classification everywhere. With these, we need to have a consistent confidence score that has the meanings of those 4-point grading scales that you have. And I'll talk about this score range in a second. But we want to be able to distinguish between a major reference, a significant discussion, and a minor reference. And kind of a little, say, why 50 to 99? A little bit of history there is we first started putting scores in documents now 25 years ago with the smart indexing technology. And that ran on a mainframe, and going from 99 to 100 is an additional character or field in the data structures. Plus, nobody ever says that they're 100% sure, right? And then we did display these, you'll see later, with percents on them. And you'll see some examples. And why say something's about a topic if you're less than 50% sure? So that's, we go 50 to 99. The 85 and above break was just because you don't want to be too much below 90 to say it's a strong reference. I mean, it is arbitrary. So but the key is, we need to output consistent scores that are in the ranges with these meanings. So, okay, next slide. Okay, now let's just state the obvious and here on this slide, but we classify topics to documents, and then through some mechanism, and we'll talk about a couple of the approaches to how the scores are determined, at least the ranges. But we assign a confidence score that has a consistent meaning. And then the second thing, again obvious, is let's leverage those scores to do powerful things for our customers. There's a few listed here, and you'll hear some more about that later. So next slide. Okay, let me look at, this will be an example of, we have Boolean rules, among other things, because this goes back for a time, and lawyers are very particular about specifics, and they like the control of these things, and it's been around for a while. But we'll talk about how Boolean rules, we get a confidence score. So obviously a Boolean rule is a yes or no thing. It's a classification, right? It does or it doesn't match the Boolean logic. Now, we don't use a search engine. We process one document at a time. So kind of, if you think a search engine is one unknown in advance Boolean query against millions of known in advance documents. That's your search index, right? Here we process one document at a time, and for US, we have like 17,000 topics, and for Canada is around 4,000 topics. So we have one unknown in advance document versus thousands and thousands of known in advance Booleans, but it is pretty much the same. So when this Boolean search is evaluated against the document, or the thousands of them, but let's just say this one, is evaluated against the document. If it matches, if the logic matches, then we need to say, hey, is it a weak reference? Is it a strong reference? So kind of how do you do that? Our documents vary. Even cases will go from half a page to 50 or 100 pages. And so when we apply the Boolean logic to a document, we can extract a bunch of features out of this. And we pick, they're basically search engine features that are used as levers for ranking. And I mean, there's nothing new really here. And we had thousands of human annotated, lawyer annotated topic document pairs in the 1 to 4 scale. And we trained on the major minor boundary that we kind of will emphasize in other places. And we tried like gradient boost, support vector machines, decision trees, etc. And it turned out that linear regression worked as well, and in many cases better than those tools, those different types of models. So because linear regression is so easy to encode into our proprietary kind of unique fabrication system, we chose linear regression. So
yeah, so we did release that Boolean-based confidence score last year. So after it went out in production, we wanted to do some testing to measure its accuracy. So we did a lot more gradings in the production environment, and we were measuring how good was the confidence score in making that distinction between the major references and the minor references. And what we found was that the confidence score was really good at identifying very strong results and weak results. So when it gave a score of 92 and up, 85% of the time, those were indeed major references. And when it gave a score of 50 to 59, 79% of the time, those were indeed more minor references or more marginal results. So, of course, what we want to do is use that in search and somehow boost the results with the highest scores, because that translates into putting the best results at the top and the weakest results at the bottom. So you get potentially a significant impact in the relevance of your top results. And there's no negative consequence if we apply this in search. We're not changing recall. We're not cutting out anything. We're just changing the order of the results so that the ones on the top have the most aboutness. And smart indexing now.
Oh, okay. So smart indexing, it's 25 years old now, so it was a rule-based system, and we didn't really have the machine learning tools back then, but it's a term weighting and frequency tool. We grouped the terms, and you saw an example of a smart indexing rule, into what we call word concept buckets. So there's groups of terms in buckets. And each of these buckets has a frequency limit, the maximum amount that can contribute to a score. And then each rule has a threshold, so if you achieve and I might add, we break our documents into consistent sized chunks. News is very, very consistent. We apply it elsewhere, we break it into chunks. So if you meet the threshold, you're at a major reference, and then there's some magic figuring out what score it gets from 85 to 99. So we go to the next slide. Now, deciding if something is a passing reference is really an exercise in disambiguation. So I have these word concept buckets with different frequency limits. So the lower the frequency limit, the more kind of ambiguous term is to a document. So it's really an exercise in, do I have enough variety from different word concept buckets to disambiguate? And if you do, and there's a little more details there, you have at least a passing reference. And again, there's magic determining the score, but the actual 4 buckets, and especially the 2 buckets of the 2 score ranges, We do try to, in other ways, make a really smooth, consistent application of the score ranges so that you don't see clumping up different spots. But that's, next slide.
So we've been fortunate that from the inception of smart indexing, you've seen the tagging of all of our topics on a document along with the scoring. And that's what we're trying to get now for news as well, or I'm sorry, for legal as well. So this is a document about cryptocurrency, and this is the beginning of the document. If you scroll in our Nexis product to the end of the document, it will show you all of the classification that's applied to this document. So you can see in subject, organization, and industry, all of the topics that were applied here. So cryptocurrency in this case got a 90% hit. Now, if you were seeing that your top documents were maybe in that 60 to 70% range, and you're thinking, you know, these aren't as relevant as I want them to be, I really want those major passings. In our Nexis product, there is a way to do that. So you go back to your pre-filters and you select your topic, and here you can click on relevancy major terms only. So your results set, once you execute that search, you're going to see your documents for cryptocurrency are only going to be scoring at 85% and above.
So what we're trying to implement now for legal and news is, so we saw that we've got scores in our data. That's already there in the metadata. News offer it in the product via a major reference filtering, but we also want to have an algorithm that by default just sorts the results from higher scores to lower scores. So we have a proof of concept ongoing on that, an algorithm that boosts the results with the higher scores. We're looking at it for two topic search scenarios, scenario where the user runs just a topic-only search, no user keywords, and the scenario where they add their user keywords on top of the topic filter. We're expecting the impact on topic-only searches to see significant relevance improvements because basically it's the main lever coming into play, the score. There's not much other levers in there, so we should, and given our accuracy metrics, we're pretty confident that documents with a high score are really the most relevant. But when you do topic plus user keywords, you need to balance, of course, the topic, the weight attributed to the topic, and the weight attributed to the user keywords. So in those cases, the results will be more nuanced, but we're really looking forward. We are conducting human relevance testing. There are ongoing studies right now. We don't have the results yet, but we're really looking forward to see what the impact will be. But the algorithm itself takes into consideration things like the weight to give to the score compared to other levers, the weight to give, of course, to the score compared to the user keywords. We want those user keywords to not lose their impact on the search. That wouldn't, you know, if the results are good about the topic, but they not about the user keywords, they're not going to be happy about that. And we're giving a higher boost to the higher scores and lowering that boost as we go down the scores. And we don't have the results, so we can't share metrics today because those studies are not done, but I can show you our search test environment where we see the results for the topic criminal injury compensation. And on this page, I have criminal results. I know because it's R versus, that's indicative of a criminal case. So I know it's in the right area. But if I look at the results when I apply the boost, I immediately see that all the top results, or almost, have the criminal injuries compensation board in the case name, which indicates to me that these are more relevant documents because they involve the actual criminal injuries compensation board. So as I said, to be continued, but just in conclusion, our vision is, as Mark said, consistent confidence scores everywhere for every topic, regardless of how the scores are put in the content, as long as we have significant meaning and we use that same scale of 50 to 99. And then the search engine can use those scores because we need that, because our automated classification will produce a variety of results from the more very strong results with a lot of aboutness to the more marginal results. And precision is really important, but so is recall. We don't want to lose any of that recall, and lawyers don't have a fear of missing out important information. So it's the best way to boost our precision or our relevance without losing that recall. We also saw that from our experience, we need to use a combination of indexing rules and tools. There's no single superhero classifier. There's you need to use a bunch of them to tackle all the indexing challenges. We're happy to now be able to consistently track and measure our topic precision. And the confidence score also allows us to enable future opportunities. So if we're really confident with the relevance of our top result for topic searches, there's a bunch of things we can do. We can increase the classification functionality, make it more prominent, make it more easily accessible, and more easier for users to add a topic to their search. We could create related content using just those topics with the highest scores and allow users to skip from one document to another using those high scoring topics maybe as hyperlinks in the document. So there's lots we can do, even analytics using the scores that have the highest scores in anything that is topical analytics based. So there's lots of things we look forward to doing in the future. And I think that concludes our presentation. If you have any questions, we'd be happy to answer them.
Okay.
Okay, thank you very much, the LexisNexis team. So I'm going to hand this mic back to you because you're going to need it to answer the questions. If you could ask you to repeat the questions, because I'm basically going to be shouting them from up there, or whoever's going to be asking them is going to be shouting them. And so we can record it if you could repeat the questions that come in. I also have at least one question from online.
So the question is, can we talk more about how we expand the taxonomy and manage the taxonomy? Do you want to go first for legal?
Yeah, sure, I can. Well, I mean, it depends on the jurisdiction, and maybe Kimberly, you'll have a different answer. Yeah, of course, for news and business, I think the context is really big. I know that for Canada, we're not in development mode, so we're not expanding massively, but we do right now, like we try to use, it's not automated, so we've looked into that. Maybe Mark, you have some proof of concept, but right now for us as well, for Canada, we look at usage stats, we look at trending concepts, we extract. I have a really smart colleague who created a program where we can take user search terms and we have a Python. We're not coders, but he learned Python, and he has a program where we extract from those user keyword searches the most trending topics, and then we look at that and we see, oh, this topic, we don't have it in our classification, let's add that. And we look at usage stats, like we know that criminal law is our most used area. There are certain areas, labor law, family law, and we try to, when we add topics, we look at, okay, what's missing? We compare with other jurisdictions. So those are the things we do for legal. I don't know, Kimberly, if you have
Yeah, so for news, we're adding new topics on a weekly basis, and we get our ideas from internal and external customers. We're constantly gleaning the news. Unfortunately, we have a really small team, and we don't have an automated way to do it. We would love one. So we keep up as best we can. We are always looking at current events. We are looking at trending topics in general that may not be a current event, but especially like emerging technologies, we really have to stay on top of that. You know, for people indexing, we're like, hey, what's going on lately? So we had to go back and make sure Will Smith and Chris Rock were tagging appropriately lately, and revise those terms. In terms of when our topics start tagging, they start tagging from the minute they're put into production, so they're tagging from that day forward. We do a re-indexing twice a year, so that will go back and start, that will add the tagging to our historic documents. So like every 6 months that gets refreshed. Does that get all the answer? Oh, go ahead.
Yeah, we have another question, so just real quick. We've looked over the years at automatic tools like topic models over the content to look for gaps in the taxonomy, and for news it's more frequent. But no matter what, there's no automatically adding stuff to the taxonomy. There are efficiency tools that go to the taxonomists. Yeah.
Okay, thank you. So we have a question from Christian Gabor online who says, are topics manually generated, curated, or are the topics generated from the corpus?
That's a little bit similar to the previous question. So I imagine maybe that, do you have anything else to add to that? I mean, for now it's manually curated. We don't add anything automatically. We do have this Python program that we're using to automate to see which are the trending topics for legal that users are searching on with their own keywords.
I'll add something. Kind of historically, we've tried 2 or 3 times, and apply this more to legal, but to self-generate some hierarchical models, hierarchical topic models to kind of create just the taxonomy, maybe not classification rules, but a taxonomy of the law. Every time we did that, it was not in any way that lawyers think about the law. Lawyers are taught in a certain way for hundreds of years, the organization of the law, and these self-organizing models do not organize it the way lawyers do, if that tells you something about lawyers. Sorry, she's a lawyer. Okay.
Non-practicing lawyer.
Do we have another question from the audience?
Yeah.
Yeah, okay. So for having a bilingual corpus like for Canada, how do you get the classification rules to make similar classifications? Because I imagine you'd have one that's written with English terms and one that's written with French terms.
Yeah, so the question is, in Canada, we're a bilingual jurisdiction with bilingual content, French and English. How do we make that consistent, and how do we tag that content? So we do have French rules and English Boolean rules, and the same. So when we hired indexers, they were bilingual. So the same person who writes the English rule writes the French rule, and they write it in approximately the same way. So that leads to somewhat, there's a consistency there. We've used machine learning for English, but not for French because it was too big of a level of effort to implement it for French. Confidence score, there's no impact because we're looking at a model that doesn't speak, it speaks linear regression.
It speaks term hits
Yeah.
and locations, densities.
Yeah.
I mean, there could be variation in the way French and English is written, but.
So it's kind of similar for news too, because we do English, French, and German on my team. And so for French and German, we have bilingual speaker, or one for each. So very similarly, we write them in English first. Our bilingual speakers take a look at that for consistency's sake. But it's obviously very important that they know the colloquialisms, because news is crazy to write for the indexing. But yeah, very similar.
We are still doing the juggling with the microphone this time. So did you have to, this is Valerie Miller from online. Did you have to factor in higher scores always showing up on longer documents? The more sentences, the more occurrences, the higher the aboutness.
Yes, we did. Now, the linear regression model with all those features took care of that, but in other technologies, where, for example, the rules that you wrote, they have a threshold, and you can't run short documents, long documents. That's obviously a question. So a common practice, this isn't a giant trade secret, is you break the document up into pieces and you classify them individually, and then probably the secret sauce is how do you roll up those individual classification results into higher scores versus lower scores. So it might be something like how many chunks of the document were about the topic gives you higher scores. There's lots of other things that we did. That is a common practice too. Normalization by document length is a troublesome one. So that's some of the features we showed you were to take care of that.
Thank you. So we've got time for one more question from the audience.
I was just wondering do you guys have documents in your index that are multilingual in the same document? And if you do you apply both taxonomies and which one you show the user at the bottom of the document? And also, if you have time, when a user queries for a multilingual, or rather if the search engine returns a multilingual document to a user's query, are there performance implications because you have to pull in both taxonomies to spit back out a document?
Well, the
Repeat the
taxonomy-
question. Do you want to?
I'll repeat the question.
Okay. Yeah, no, I guess if I remember correctly, it's like when you have documents that have both the English and French content. For example, multiple languages, the same document. How does that work? Does that impact performance? How do we show the topics? That we don't show the topics, so I don't know if you have an answer for that. I can tell you for us, we basically apply the same taxonomy to all of our documents, and so all of our documents go through all of our rules, and they will get classified with. I mean, some of our rules, if we have one rule with a French and an English search, because that happens because we're complicated in Canada, we will just pick one of them. It's the same code, it's the same topic, but we have English only rules, French only rules, but all the documents go through all the rules and they get classified accordingly. So there's no performance issue really, because it gets done at enrichment stage. But yeah, I'll pass the mic to Kimberly.
Yeah, my answer really is pretty similar. It's funny because we'll go through our test results, and in fact, I just got this question the other day from a customer, like, why is this Chinese document tagging for? God, I'm hung up on Will Smith today. It's in my. I'm so sorry, but it was. It's just odd to see that, but really, thankfully, there's no performance issue as it's running through the fabrication process. Did we get everything in your?
Yeah.
Oh, okay, great.
For the legal stuff, when you pick a language for the taxonomy, is there a confidence score in that? Like, based on the document makeup?
Oh, right. You mean, do we predict the language of a document? Yes, there is a language filter on Lexis Advanced for Canada, and I am not super familiar with how they do that. They must have some sort of algorithm. Maybe someone else in the room knows.
In most places, we get content from a source. So for most sources, we know that they're primarily English, primarily French. And now
We do have bilingual sources in Canada.
Right, but I don't know how we put a language tag on the document so we can filter them. I don't know if we do any fancy language detection. I'm not in that part, so yeah.
Okay. Thank you all for your questions. I'm sorry we have to end it there, but please give a round of applause for our presenters from Lexis. Thank you so much.